Now for the seventh question, we first have to obtain a quadratic equation in terms of cos theta, and then we have to solve this equation. So first of all, we'll convert this to the quadratic equation of cos theta, and then we'll just solve it ahead to get the values of theta that lies in between 0 to 360. So now to start with, we are having the tan theta. We can write tan theta as sine theta over cos theta, and it's multiplied with sine theta to be equal to 1. Now I can write the same thing as sine square theta divided by cos theta equal to 1. Now I know that sine square theta is written as 1 minus cos square theta because the formula that we are using is sine square theta plus cos square theta equals to 1. So how can I convert my sine square equals to cos square? By just making sine square the subject, which is same as writing 1 minus cos square theta, right? So that's what I'm doing over here. So it is writing as 1 minus cos square theta divided by cos theta equals to 1. And therefore, the final quadratic equation that we'll be having will be 1 minus cos square theta equals to cos theta. And this implies it's cos square theta. I'm shifting everything towards right, plus cos theta, right? Cos square theta plus cos theta minus 1 is equal to 0. So that's your final quadratic equation in terms of cos theta. We started with this and we got this. Now we can just assume this is a quadratic equation and now solve for cos theta. So let's see what is cos theta equal to by using our calculator. So in my calculator, I am substituting the value of A, B, C as 1, 1, minus 1 respectively. So 1, 1 and minus 1 is giving me the values of cos theta as minus 1.618 something, and the other value of cos theta that I'm getting out of this is 0.6180, right? And yeah, the way that we get the answer is by implementing the quadratic formula, that is minus b plus minus square root of b square minus 4ac divided by 2a. That's the formula, right? So that's the formula we are implementing, where b values are equal to 1, a value is 1, c is equal to minus 1. So that will be the two values of cos theta that we got. Now after this, we have to find the value of theta because cos theta is not asked, theta is asked. Now clearly this value is less than minus 1. So we are going to reject this solution because we know that cos graph basically lies in between minus 1 and 1. This is your minus 1, this is your 1. And there is no value that you get for anything that is beyond negative 1, right? So this will be simply rejected. We are left with cos theta is equal to 0.6180. So let's continue with that. So cos theta is equals to 0.6180. Now you need to know how you can solve this with the help of multiple techniques are there. I'll be using the cast diagram technique. All right, so I always use this, okay? So here is my cast diagram, where I know that cos theta is positive in the fourth and the first quadrant. This is, everything is positive. Over here only sine, over here only tan, and over here only cos. So I know that my cos is, the value of cos is positive 0.6180. So the lines will come in the first and the fourth quadrant. This is called the basic angle, which is the inverse of the value written over here. Even if it was negative of this value, the basic angle is always found out to be inverse of a positive value, right? So this is my basic angle, right? And I want to find in between 0 to 360. So that's the basic angle is my first solution. Second solution, 60. From the 360, we are taking away this basic angle, right? So this is also a basic angle. So from the 360, if we remove the basic angle, you get the second value. So that's your theta 1 and that's your theta 2. So if I have to write my final solutions, first of all, I need to find my basic angle, which is cos inverse of modulus of whatever is the value written on the right. Modulus is nothing but it converts negative also to positive, right? So the value that we'll be writing over here would be cos inverse. Make sure that you are in the degrees mode. So cos inverse of 0.6180, it's 51.8297 something. And so that's your first solution. And your theta 2 is equals to 360, the full 360 minus that basic angle. So this will give you the answer of 308.170 something. So what are the final answers of first part of question 7? So my theta values are 51.8 correct to one decimal place and 308.1, both of them as I mentioned correct to one decimal place, because that's the format that we want to give the answer, which is mentioned on the first page itself, right? So yeah, that's about the first part of question A. Let's move ahead. In the second part, we are having to prove something, right? So now this proving questions, it all depends on how much practice you have done in proving this, all right? So even if you're having, let's say, a lot of practice, you may still get stuck into this kind of problems. So yeah, just make sure that you are having a good amount of practice of this. And it's all about luck. If the method hits you in the examination, you are able to solve it, or else you won't be able to do it. And all this kind of trigonometric questions of proving something, you just keep it at the last, right? So that you're not wasting a lot of time in just proving it. So let's say we are starting with tan theta by sine theta minus sine theta over tan theta, and we have to convert it into the RHS, that is tan theta sine theta. We could have gone in the opposite way as well, but I think that going from left to right would be a better choice. So left hand side is equivalent to tan theta can be written as sine theta over cos theta. So sine theta over cos theta. There is also sine theta, so it will become cos theta sine theta minus sine theta divided by sine theta over cos theta. But now that divided by cos theta goes on top. All of these rules are like, the part of your algebra, right? So yeah, that's what I'm applying. And then now this will go ahead, continue, and become, let's see, what does this become? This sine theta and sine theta gets out. This sine and sine gets out. So I'm left with 1 by cos theta minus cos theta. And now if I just go one step further and take a common denominator, so 1 minus cos square theta divided by cos square theta is what I'll be getting. I'm simply multiplying this and dividing this by cos theta to get a common denominator of cos theta, right? So that's the next step. Now, because we want the answer in the format of tan and sine, how about if I convert this into that format itself, right? So what I can do now is I can say that, okay, first of all, because there are two terms over here, I would like to get rid of this one. I would like to get rid of this one, right? I don't want one minus something. I just want one simple term. So I'll first convert this cos square theta into the sine square theta format. See, this is something which I am doing based on my experience. One can do it in multiple different ways, okay? At the end, what matter is the left hand side should be equal to right hand side. So over here, I'm going to do 1 minus, I know that cos square is nothing but 1 minus sine square theta. Again, I'm using that same formula that I had shown in the previous part, which is divided by cos theta. Now I can write this cos theta as we know that tan is equals to sine over cos. So I can say that cos is what? Cos is, or else let me just keep it cos. I don't need to change it. Let's just see what do we get, because I guess sine over cos will be coming out to be tan in any way, right? So let me not change that. Let me just keep it cos theta, right? I'll just not change that. So 1 minus sine square theta divided by cos theta. And now if I simplify this, this will be same as writing. This 1 and 1 gets out, minus minus becomes plus. So we're having sine square theta, which can be written as sine theta into sine theta, right? Divided by cos theta. So this is same as writing sine by cos is nothing but tan. And yeah, that's it. We are done. This is tan theta, which we called by sine by cos. And this sine theta is already there. So this is equals to your RHS. And we are done with the proof as well. So yeah, that's the end of question 7.